Hello and welcome to today's lesson on distortions due to forces. Our plan for today is as follows. We'll begin by explaining how forces can change an object's shape as well as motion and introduce this as a distortion. Next, we'll give an overview of 3 types of distortion a force can enact. Finally, we'll highlight the multiple forces at work in a distortion. So far, we have explored how forces can affect the motion of objects, such as causing acceleration or deceleration. We also learned that forces can act in various ways, including contact or non-contact actions, and produce different outcomes depending on their direction and magnitude. Building on this foundation, we can now understand how forces not only change an object's motion, but also its shape. This will broaden our comprehension of the numerous ways forces interact with materials and lead to various types of distortions, enhancing our overall grasp of physics. When forces act on an object, they don't just change its speed or direction. They can also alter the shape of the object. These alterations in shape due to the application of forces are called distortions. We see distortions all the time, whether it be a folded sheet of paper or a crushed can. Bending happens when forces act perpendicular to the length of the object. When such forces are applied, they cause the object to curve or bend. For example, consider a diving board. When a person stands on the end, the board bends downward due to the gravitational force acting on the person. Here, the force is acting at a right angle to the length of the diving board, causing it to bend. Stretching occurs when forces act to pull an object apart, elongating it along its length. A common example is a rubber band. When you pull a rubber band from both ends, you are applying forces in opposite directions, which stretches and elongates the rubber band. The material of the rubber band resists the forces slightly, but eventually stretches due to the tension created. Compressing is the opposite of stretching. It happens when forces act to push an object together, reducing its length or volume. Think about squeezing a sponge. When you press a sponge from both sides, forces are acting inward, causing the sponge to compress and decrease in volume. The material inside the sponge gets pushed closer together due to the applied forces. For any distortion to occur, forces must act in pairs. A single force alone will not cause a distortion but only move the object. This is because distortions like bending, stretching, and compressing require balanced forces that create tension or compression within the material. In bending, one force acts downwards at the point of application, while another force acts upwards at the point of support. At the bottom of the material, the force compresses it, and at the top, the material is stretched, causing it to bend. In stretching, forces applied in opposite directions along the length of the object cause the material to elongate. The opposing forces pull apart the material, resulting in its extension. In compressing, forces acting inward from opposite sides push the material together, reducing its length or volume. Without the opposing force, the object would simply move rather than compress. In today's lesson, we examined how forces can alter an object's shape, a phenomenon known as distortion. We identified 3 main types of distortions: bending, stretching, and compressing. Bending occurs when forces act perpendicular to the object's length, as seen in a diving board. Stretching happens when forces pull an object apart, elongating it, like when a rubber band is stretched. Compressing takes place when forces push an object together, reducing its length or volume, such as when squeezing a sponge. We also discussed why multiple forces are required to create these distortions. A single force would merely move the object, but paired forces enable the necessary tension or compression within the material. In bending, opposing forces cause compression and tension at different points, resulting in curvature. In stretching and compressing, forces act in opposite directions to extend or reduce the object's length or volume. By understanding these principles, we gain valuable insights into the interaction of forces with materials, which is essential in fields like engineering and materials science. This foundational knowledge helps in better designing and using materials in various practical applications. Watch the rest of the GCSE Physics course at Sophos Education.